All right, welcome to lesson 1.5, conditional statements, day 1, where we can start with our warm-up right here, where we're talking about deductive reasoning. So deductive reasoning is a type of reasoning that reaches conclusions using accepted facts, definitions, postulates, or proven theorems. So premise 1, if a phone's battery level drops below 20%, then the device automatically enters low power mode. So premise 2, Mia's phone is currently in low power mode. So what is the conclusion that we can make from that? Therefore, Mia's battery must be below 20%. So this is false. Mia could have turned on her low power mode and she could have had the battery percentage be at 42%, and she could have selected that to save her battery. So we don't always have exactly what we have, so we need to look at our facts and make educated guesses on these decisions. So what can you deduce? Read the following statements and determine if the reasoning is valid or invalid. So statement A, if we have a polygon as a square, then it has 4 right angles. All right, so we have a polygon X and it has 4 right angles. So we are going to think that, hey, this shape X must be a square. But think about it for a second. Is a shape with 4 right angles only a square, or are there other shapes that have 4 right angles? I'm going to say that this is invalid because a rectangle also has 4 right angles and is not a square. All right, let's take a look at statement B. In your first premise, you have an angle that measures 90 degrees, then it is a right angle. So if angle C, measures to be 90 degrees, therefore angle C has to be a right angle, right? Well, is there any other measurements that make right angles? No. So would this be invalid or valid? This is going to be valid. Why? Because if an angle is measuring 90 degrees, then it must be a right angle. That is the only way that we can go about that. So valid, an angle measuring 90 degrees must be a right angle. So this kind of goes into what we're talking about with conditional statements. A conditional statement is an if-then statement that relates to a hypothesis, the part that follows the word if, to a conclusion, the part that follows the word then. We represent this as the letter P with an arrow going towards the letter Q, and so we read this as if P, then Q. So over here, if you give a mouse a cookie, then he is going to ask for a glass of milk. Well, after the word if is the hypothesis, which I can label with the letter P. And when I highlight the hypothesis, I want to make sure I do not include the word if. So then if I want to highlight the conclusion, it is everything that follows the word then, and I do not include the word then. So he is going to ask for a glass of milk. So that is how we correctly identify the hypothesis and conclusion. Make sure we are understanding when we do that, we are not including the words if, and we are not including the word then. All right, let's go to the next page here. So in our example, let's write the following as a conditional statement. So this is where we're writing it as an if, blah, 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 then blah, blah, blah statement. So you can register to vote if you are at least 18 years old. Well, if you are what? If you are at least 18 years old, then you can register to vote. So we are taking a statement and we are making it into a conditional statement. So if you are at least 18 years old, then you can register to vote. So let's go ahead and have you try it. Read the conditional or the statement and then make a conditional statement based on that. So I'm going to give you a couple second head start when we do this. If you're watching this video, it'd be a good way to pause the video and try it yourself. So a triangle with all sides congruent is equilateral. So if I have a what? If I have a triangle that has all sides congruent, then I can say it is equilateral. So again, if a triangle has all sides congruent, then it is equilateral. All right, let's try that with another one. Alberto can go to the movies if he washes the car. So what happens? If Alberto does what? He's got to wash the car. So if Alberto washes the car, then what can he do? Then he can go to the movies. So put that together. If Alberto washes the car, then he can go to the movies. So whenever we make these statements and put these statements into an if-then conditional statement, we want to test the truth value of that statement. So that is basically us stating, is it true or is it false, according to whether the statement is true or false. That's our truth value. Note over here on the right side that in highlighted, a true hypothesis and a false conclusion has a value of false. So this is our table that we can follow, but a truth table lists all the possible combinations of truth values for two or more statements. So typically you have to have them be true, true to make it true. If it's false, false, then it is also true. But if one is false and one is true, then it is not going to work for us. And then if I switch it the other way, it can be true. So you just got to pay attention and read it and see how it works out. So determine the truth value of each statement. Write a counterexample if possible. So a counterexample is just us providing an example of how this would be proven to not be true. But we have to first determine, is this true or not? So if a number is even, then it is divisible by 2. Can you think of any number that is even that is not divisible by 2? Right? 200, that's even. Half of that is 100. So that is easily divisible by 2. And when we say divisible by 2, we mean, can it divide by 2 and result in a whole number? Yes, this is true. It happens every single time for us. So are we able to provide a counterexample? No, we are not. So we need to state no counterexample is able to be provided. All right, let's try that with another example. If an angle is obtuse, then it measures 100 degrees. Well, if you think about it, that is a true statement. But if an angle is obtuse, is its only measure 100 degrees? Or can it be other measures as well? Well, what happens if it was 101 degrees? Is that obtuse? Yes. Is that what we originally stated in our if-then statement? No, it said 100. So we would say that this statement is false. Our counterexample that we can provide is that an obtuse angle could measure to be 101 and it still works for us. So we have to make sure it follows our validity of our truth. All right, let's go to our next page here and let's try it with a couple different other examples. So what is the truth value of each conditional statement? So if a quadrilateral has a right angle, then it is a rectangle. All right, so think about this. If a quadrilateral has a right angle, then it is a rectangle. Is the only quadrilateral that have right angles a rectangle? No. I could say a square has right angles, right? Or if it has a right angle, right, it's not necessarily a rectangle, or if it is a quadrilateral with angles 90, 80, 100, or 90 degrees, then it is a right angle. So for us, we are proving this statement to be false. What is our counterexample? A quadrilateral could have a 90-degree right angle, but it could have other angles that are 80 and 100, and another one that's maybe 90 degrees. And those have a right angle, but if it has 90, 80, 100, and 90 degrees in those corners, that does not make it a rectangle, but it's still a quadrilateral. I know that may be a little confusing because we haven't even talked about quadrilaterals and rectangles and squares and all that good stuff yet, but that's what fits the true definition of what a quadrilateral is. A quadrilateral is just a shape that has 4 sides, and it is enclosed to add up to equal 360 degrees. Okay, so this is false, right? We could think of other angles, and it is not a rectangle because 90, 80, 100, 90, that 80 and 100 makes this not a rectangle. All right, our next one. If X is the midpoint of line segment AB, then point X is going to lie on AB, right? Well, let's draw a line A to B, and if X is the midpoint, is it in between A and B? Yes, it's true. I don't know where else I could put it. So if I can't prove it to be false, it's true. And can I provide a counterexample? No. So this would be no counterexample. So this is just kind of wrapping up all that we've talked about here. The definition of a conditional statement is we have a hypothesis, which we label with the letter P, and it follows the word if. And then it has a conclusion that follows the word then, and we label that with a Q. The symbol that we use that is we go from P to Q. Sorry, those were supposed to stay right there. So our symbol for a conditional is from P to Q. If I want to write a converse, what I'm going to do is I'm going to switch that hypothesis and conclusion. So instead of going from P to Q, this is going to go from Q to P. And then a biconditional is the combination of a conditional statement and its converse. So it is true when a conditional statement and the converse are both true and false. The way that we do this is it goes back and forth from P to Q. And the one couple words that we want to note on the inside of this is that we want to say that this goes in the wording of if and only if. That is what goes in between. So this time, we are not writing it as an if, blah, 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 comma, then blah, blah, blah statement. It slaps in the words if and only if in between the hypothesis and conclusion. Okay, so let's just practice these. It's the only way that we can get it down. All right, so let's write and evaluate the truth value of the converse. So we're going to write the converse statement. And the first thing I want to do is I want to underline everything after the word if, and I'm going to label it with a P for my hypothesis. Everything after the word then, I'm going to underline and I'm going to label with a Q, and that is my conclusion. So for us, what is happening for the converse is we switch these. So instead of saying if you post a video that is trending, we're going to say if the Q part, your profile received at least 10,000 clicks. So the converse is if your profile receives at least 10,000 clicks, then we can state the hypothesis. Then what did you do? You posted that video that is trending. So the converse, we switch around those two statements, and we are not switching the words if. The if is still at the beginning, and the then is still in the middle. We just switch around the hypothesis part and the conclusion. And remember, the hypothesis doesn't include the word if, and the conclusion doesn't include the word then. So if your profile receives at least 10,000 clicks, then you posted a video that is trending. So we are going to test its validity. We want to say that this is false because this is not a true statement. I could have shared an old post and it could have got 10,000 clicks. That doesn't necessarily mean that it's trending. That's debatable. That's what's good about geometry, is that we can debate these kind of things about its true statements. But this would be false because I could prove it otherwise. All right, so let's try it for ourselves. Again, underline and highlight everything after the word if, and we're going to label it with a P. Highlight and underline everything after the word then, and you're going to label it with a Q. So we're going to switch those around. So I'm going to say if it has 4 sides, what is it? It's a polygon. So if a polygon has 4 sides, then I can state the beginning hypothesis part. It is a quadrilateral. So I'm just switching the statements back and forth. I want to test its validity. That is going to be true. And I can't provide a counterexample. because it's a true statement. If it's a polygon that has 4 sides, then it's a quadrilateral. That's the definition of quadrilateral. It has 4 sides. Quad meaning 4. Let's try it with another one. If a number is prime, then it is odd. We want to switch those around. So we are going to say if a number is odd, then you can state the beginning part, it is prime. So the converse is if a number is odd, then it is prime. Well, let's test our validity on this one, our truth value. Well, if a number is odd, then it is prime. Let's think about prime numbers. Well, the number 3 is a prime number. That's odd. The number 7 is a prime number. It's odd. 5 is also that way. 9 is an odd number, but it's not prime. 9 can be divided by 3, and prime means it can only be divided by 1 in itself. So we would say false. And we proved it with another example, a counter example, that 9 is odd and it is not prime. So we proved it to be wrong, testing our truth value. And how did we do that? We provided a counter example saying 9 is odd and it is not prime. Last page. All right, let's try it. But this time we are going to write the biconditional. So remember, we are going to get rid of the word if. We are going to get rid of the word then. And in between them, we are going to write if and only if. So I take the 2 angles are congruent. I start with that. And in the between their measures are equal, I put in the words if and only if. So I'll read that all together. A biconditional is 2 angles are congruent. And I spelled congruent wrong. I just realized that. If and only if their measures are equal. So let's test its validity on this one, all right? 2 angles are congruent. Can they be congruent and one be 25 and the other be 30? No, they have to be exactly the same. So this is a true statement. And how is this true? Is because the conditional, if 2 angles are congruent, then their measures are equal. It is also true for that. And then if I stated the converse, it would also be true. So if I made that backwards, if their measures are equal, then they are congruent. Well, that's true as well. So if I flipped it around saying the converse, that would also be true. So we're testing its truth value from the converse and the conditional statements. All right, let's go to our next one here. All right, rewrite the following statement as a biconditional and determine its truth values. Remember, we're going to get rid of the word if, we're going to get rid of the word then, and in between, we're going to put if and only if. So our biconditional statement is, you play football if and only if you are an athlete. So let's just worry about writing that statement down first. The biconditional, we get rid of the word if and then, and we put an if and only if in between those two. So you play football if and only if you're an athlete. Now let's test the validity here. Well, I played basketball and I was an athlete. Maybe I was close to an athlete if I think I was, but I didn't play football. So this would be a false statement. How? Because we can provide a counter example by saying a basketball player is an athlete and he doesn't play football. Well, you could say a baseball player is an athlete but doesn't play football. A cheerleader is an athlete but they do not play football. So any way to prove this example to be false.